No! Don't worry guys, my Commodore 64 is not dead, having just refurbished it in the start of the last video series, which was called Refurbish This. So this video series is going to follow the evolving thought process of solving a common problem. And in this case, the problem is this. Commodore 64 power supply. This tends to blow up Commodore 64s. Now I'm going to attempt to solve this problem by showing you how to create a cheap, amazing looking, easy to build replacement power supply for about 30 bucks that any of you can build at home. And I'm going to call this series So Then I Thought. Hit myself in the face with it. That's not the least of its problems. Over time, and it's been quite a lot of time, the 5-volt line can start to put out more than 5 volts. Once it hits about 6 volts, it's going to give you some fried chips, and not in the good fish and chippy kind of way. The reason this is so freaking heavy right now is because it's 2 power supplies in one. It actually contains a 5-volt DC power supply and a 9-volt AC transformer. 9 volts pretty stable. It's the 5 volt that gives us problems. I sort of thought about this and I thought, they make these replacement power supplies, but some of them cost $90 and they're big. Okay, you've got the $90 ones. And if you go to the other end of the spectrum, take a look at this. This uses a Samsung USB charger, plugged straight into the Commodore. There are a few people who are skeptical, to say the least. And it also has downsides. It can't power the onboard clock. And then in the middle of that spectrum, you've got people like the superb Jan Bieter, and he's created this. So what he did, he took a PlayStation Portable switching power supply, put it into a bare bones case, and added in, with a lot of soldering and wire insulation and some fuses, a 9-volt AC transformer. But some of us may not want to do all the soldering and maybe looking for a simpler solution. So then I came across these. So this is made by a guy called Ray Carlson. This is his admittedly bare bones wall wart solution. And we call them wall warts because when you plug them into the wall, they look like they're not very pretty. And it comes with the cable just sort of threaded together here in places. Now don't get me wrong, he is fully transparent. This is a cheap, bare bones solution using wall warts. But who wants wall warts? On the end of it, you've got the Commodore 64 DIN plug. So really, all this is, or should I say, so then I thought, really all this is 2 power supplies wired into one plug. Now I can plug these in side by side into a power strip. So then I thought, why don't I use one of these? This is a power extension cord. You've probably got one lying around in the house. So my thinking was this. If we plugged one of these in to one end, one in the other, you've kind of got one unit. Okay. So I ordered essentially the same transformer that Ray Carlson uses. It is advertised as output 9 volts AC 1 amp. So we plug that in there. So then I thought, we just use the USB plug similar to the Samsung in the other one. We've all got some of these lying around the house. You just need to make sure that it's 5 volts and at least 2 amps. The bigger the amperage, basically the cooler it's going to run. Now I found another one lying around. That one was 2 amps. This one is 2.5 amps. In theory, that one's going to run a little cooler. Now, experimenting around and kind of treating these like Lego, I realized that was a really neat little contraption about the size of a power supply housing. So then I thought, why don't we just put the whole assembly in the power supply housing with the one mains cable coming out through a hole box here. And then all we have to do is take a USB plug, chop off this cable, and wire those into our old, untrusty Commodore 64 power supply's DIN cable. There's your cabling, there's your DIN, and let's be honest, we're not going to use these if we're already afraid that they're going to give out too much voltage. So, let's get started. So, we've got a lot of the stuff already for this project. What we're still waiting on is the case. Now, I was able to get the manufacturer to send me a diagram of the case, so we can see that it's got this really neat ventilated slat arrangement, which I thought reminded us and was evocative of the Commodore Amiga and C64C. So I think that's going to look really nice, but we'll have to wait for it to show up. In the meantime, we can get started on some of this testing. What I actually want to do is test my existing Commodore 64 power supply unit and see if it is getting anywhere close to the dangerous levels that we've talked about. So here is the Wikipedia. So we can see from this that anything above 5.5 is a major concern. So there are people online saying how these supplies are dropping like flies. Hey, that rhymes. Yeah. What did the janitor say when he burst out of the cupboard? Supplies! Okay, sorry. So this is the pin out. So looking at this, it's then pretty easy to see. We've got 9 volts AC here and here. We've got 5 volts DC and ground up at the top. So that should enable us to test this with the multimeter. Ta-da! It's going to allow us to hold the DIN plug in place while we test. And it also makes a great pen holder for my Skywalker Ranch pen. Oh, by the way, if you didn't know that that doesn't work as well as I thought. So, pen in the holder and multimeter out. Alright, so what we're looking for is a nice, clean, approximate 5 volts. So, apparently we have a 12 volt power supply. I am so glad that we did not plug this into my Commodore 64. Oh my gosh. Alright, well let's compare this with our USB. Don't try this at home. See, that's what happens. Okay.
So ground is on the right, 5 volts from the left. Let's test it with a last 5 volts, 5.8, 5.9. Let's do it. Oh yeah,
These both seem good, but we should try this as well.
Not DC, this is AC, so this is going to be pretty easy to measure. There we go.
So I have no hesitations using this. Now a lot of the people out there do use fuses in their supplies. My thinking is this: we have these huge power supplies for the Commodore 64, but technology has evolved so much over 30 years that I believe it's really overkill. I've never known one of these start giving out more voltage than it was meant to. And the issues with the Commodore 64 supply have happened over 30 years, so putting a brand new, modern technology branded power supply, I don't think we need to fuse that. So I'm going to do it without a fuse and just keep it simple. Okay guys, guess what's arrived? The case that puts the sexy in sexy PSU. That is actually really sexy. Look at that. It's really nice. So now the moment of truth. Let's see if the arrangement is going to fit. Okay, so here's our idea. Please fit. Oh my goodness. Now, is it tall enough? So let's think about this. So this is going to come out this way. This is going to bend and come out this way. And our USB is coming out with this. Let's pretend that piece is in there. We'll just take it out for now and just test the height. This is the tallest part. You can see if everything fits. Obviously that's going to be in there too, but whatever. Moment of truth. Yeah. That is tight. Yeah, let's just try screwing this in. See how far down we go. Guys, this feels good. And you know, I would rather that it was a millimeter too small than, you know, an inch too big. That's what she said. Actually, I don't think she ever said that. You get my point. We want to make this cheap, sexy, easy to build, but also compact. Because things have evolved. Things have evolved since 30 years ago. Look at that! Guys, this is beautiful. The issue as it is this little bit of bulge here. And hey, a little bulge never hurt anyone, right? Right. Good. Next up, now I want to make sure there's going to be enough space for the USB cable to come out of here and connect. That's going to be too tight. So, yeah, we might have to go back to this 2 amp. You know, that 2.5 amp one, half an amp's not going to make the hugest difference. I mean, we're not talking about a lot of heat either way from one of these little things. Right, I guess it's time to cut this cable. Don't need much coming out. Maybe something like this. And let's strip it down. So this is going to represent the 5 volt and the ground line. Yeah. We just need enough copper wire to carry those electrons. So into the ground. Okay. You know, the whole point of this really is to make something that you can fit together easily at home, kind of almost like Lego with those USB plugs. And then we don't want to complicate things at the cabling stage and you know, make it required to do soldering and all that stuff. So I bought a pack of these. You can get these at your local hardware store. Come in a variety of sizes. These are crimp and shrink butt splice. Very American. In England, I think these are called bum splice. Anyway, the point is you can shrink fit these using heat shrink. So you can heat them up with a lighter or actually the tip of a soldering iron. Tends to work quite well. So we'll get the smallest ones we can find. Slip one over the line. Put the cable into the metal. So I'm just going to clamp one end down. Yeah! Ah, it feels so strong. Stick it in the hole. one end down again. Nice. It's taking shape, guys, so hold the line. Okie dokie. Unfortunately, I don't have a big lighter, so I'll have to use this small one. Should be able to just heat this up. It'll shrink to fit. Kind of goes all droopy when you put it in the hole. This is half of our assembly. The other half, obviously, going to use this. So again, we've got to chop this up. Don't need that. Definitely a more sturdy chunk of wire here. It's 9 volts, so you can expect it to be thicker. Oh yeah, perfect. Didn't know I could make such noises. Alright, there we go. It's taking shape, guys. We now have our 4 pins. It's good to put a naked flame on your butt splice. I'm kind of a perfectionist. I'm going to tidy these up. What this shrink wrap cabling splice, butt splice, does as well is actually holds the cable in place, not just at the crimp, but at the plastic shielding around the cable too. So it incorporates the whole thing and makes it one unit. Now, next up, to make it one unit, we have to determine what cable goes into what cable. Isn't that beautiful? No, it's not. What a mess! Look at this thing. I actually want to use this molded cable protector here. So in this case they are attached pretty hard, which is fine. Just give them a snip. And that one. That's lovely. I wonder if that causes cancer. Okay. That's a bit of a clean-up. Make things nice and tidy here. Look at that. Could have just come out of the Commodore factory, couldn't it? Let's get our continuity test going with the aid of Greiser's diagram. I've got my lighter holder. That's just going to get in the way. One end in here, like so. And one end here. Beautiful, I love it. So we'll do the ground first, which we can see is pin number 2. Pin 2, and it's probably going to be... Yep. So we can now write on there, ground is blue. Pen holder. Just gets in the way. I don't know why they put a pen holder there, it's just bad design. 5 volts plus 5 volts. What are we going to be here? Yep. So that is red. And true story, I'm actually colorblind. Slightly red and green colorblind. So brown is this 9-volt AC here, which only leaves one conclusion, which is that this one is black. Sure is. Okay. That's all we need to know. So we can turn this off and start wiring it up. So this is going to be so easy. Crimp the butt splice. Oh, God. And then we want a ground for that 5 volts is blue. Heat it up. Here we go. Next up, 9 volts. And heat them up. Now I'd like to check the box assembly. So that's going to go, it's going to run like that. And these two are going to run inside the box. Like that. That's basically going to be it. Can it really be this simple? I think it can. Rather than advising you to get out drills and all sorts of things like that, what I'd like to do is use this, make a little incision on this box so this can slot in, and then the case is going to slot down on top of it, which really is going to be the same as the assembly we have here. So that means all I need to do is measure this and recreate it here. Is 8 millimeters by 12. You may have a knife at home that you could use. Please just take care, whatever you do. So our center point that's essentially it, and as I say, it doesn't have to be perfect. Yeah, here we go then. So now if we score this, let's do it on the inside so we don't do anything ugly. So making little score marks, it's going to make it easy to push through. Alright, nearly took my eye out with that. But there's a hole. As with any good hole, you need to try it out. Now this case is a little thicker than our Commodore case. What do you think? It's going to look great. Just need a little more width on the base of that hole, I think. Mind your fingers. You can just shave down, basically. Shave across. Yep. Once our screws are in, that's going to be perfect. We need a hole in the other side. Looks good to me. Now, although we have the white cable, I would like the cable to match the black one coming out of the other end. So, I did buy this. This was a whopping $3.49 at Target. It's 15 feet long. They do shorter ones on Amazon.com. I'll link to those below the video. But this is going to do very nicely. And hey, you can always do with a bit more length. This thing is very long. I'm going to make another video about untangling these. I think what we'll do is get a dab of super glue on there, just to hold it nice and neat. Ta-da! Super glue loves bonding rubber and plastic, so we'll just hold that tight for a second. And I managed not to glue my fingers together like I usually do. Okay, that looks pretty good. I think we'll use a cable tie just to secure the cable and stop it from pulling. Now, probably the hardest thing about this whole project is deciding which color cable tie to use. Cable tie just goes around here. Just do it really nice and tight. So that can't pull through. Any other cable ties? I mean, the whole thing is so simple that I sort of want to do more work now. I find myself wanting to maybe tie these up or push that in. Or really, it's just sort of a self-solving system. So I think we'll just put it together then. Yep. Straighten that. Commence screwing montage. There it is. There it is. I am so happy with that. Cable's tight. Cable's tight. It looks like the original. There's no moving that. And even on the inside, you kind of see through. That's the kind of stuff you might see inside a real power supply. And that's the point, really. This is a real power supply. I do have one little thing that I splurged on just for my own satisfaction. That is this. You know, this is a Commodore power supply. So I felt we should brand it. There you go, the finished product. The $30, give or take, Commodore 64 power supply. Easy to build, sexy, compact, cheap. Alright, where's my patent attorney? Should we plug it in? No explosions. That's good. So my next step is to do a 24-hour soak test and just keep this thing running see how hot it gets, test the voltages every few hours, and get all of that done before we plug it into the real deal. But look at this. Isn't she beautiful? Update for you. I've been testing this for 24 hours and so far it's still barely even warm. The plastic is cold to the touch or room temperature. But there's only one way to find out for sure if everything's still looking good, and that is on our trusty multimeter. So firstly, the 5-volt line. Same as before. And now 9 volts. Yep. Still cool. And man, is it cool. I can't quite believe how cool this is running, but there's only one way to test this out for sure. We've been getting steady voltages for 24 hours. Now it's time to hook it up to the Commodore 64. The moment of truth. Yes. It works. What else can we test? Okay, so we're now trying the data cassette player and loading my favorite game, Ghostbusters. Alright. So let's try cartridge game. This is the brilliant Sam's Journey cartridge. It works. Well, there it is, guys, and there I am, paraphrasing Apple. It just works. If you enjoyed this video, please like and subscribe, and also please do consider tweeting about it. With these videos, time is always an issue, and I'm now a member of Patreon. Please check out the link below for some really great rewards. But above all that, I really truly hope that this has been an interesting project for you to watch and is something that you'll consider embarking upon. Until next time, cheerio.